Hello, myself Chittaranjan Mondal, Assistant Professor, Department of BSH, and Swami Vivekananda Institute of Science and Technology. Now, in this video, I am going to discuss some examples. Find the missing term in the following table. Here, actually, this is the application of forward difference operator and shift operator, backward difference operator. This is the main importance of, because we are solving this type of problems because it is very much important in interpolation. So find the problem is find the missing term in the following table. Here missing term for the nodes x1 equals to 1, here the missing term, and 0, 1, 2, 3, 4 the missing term in case of x4 equals to 4. Here how many nodes are there? Actually x0, x1, x2, x3, x4, x5. So n equals to 4. So actually x equals to x0 plus nh, xn. Here the space length is 1 because difference between 0 to 1, difference between 1 to 1, that is 1. So h equals to 1 actually, and n equals to 4. So that is 5 can be written as 0 plus 4 into 1. Sorry, n here 5, x5. So x5, actually x5 is x6, n plus 1, xn plus 1, that is x0 plus nh. So 0 plus n equals to 5. So 5 here. So as the missing term, what is the main concept? If the missing term, here missing term is 2 and n equals to 5. So in this case, 2 missing terms and nodes are 6 nodes. So this is the polynomial, third degree polynomial here. n equals to 5 and 2 missing terms. So if we represent this table in a polynomial, so this is a third degree polynomial. That's why if we apply the forward difference operator delta 4 fx obviously 0 for all x, and we know that this is the shift operator e of fx equals to f of x plus h, and forward difference operator, definition of forward difference operator is f of x plus h minus f of x. And from this, and we know that, and obviously if we derive this, e to the power n f of x can be written as f of x plus nh. If we derive this, so from here, so if we solve these two equations, e of fx equals to f of x plus h and delta fx equals to f of x plus h minus fx, we can find e shift operator equals to delta plus 1. So that is delta equals to e minus 1. So e minus 1 whole to the power 4 fx. This is the power 4. We just simplify this. E to the power fx minus 4 e cube fx plus 6 e square fx minus 4 e fx plus fx. And from the definition, e of f of x plus a, fx equals to f of x plus h, and e to the power n fx equals to f of x plus nh, doing this, we can find f of x plus 4 minus, because space length h equals to 1 actually. So f of x plus 4 minus 4, and like this. This is the main equation here. So in this equation, if we put x equals to 0, we will get x equals to 0. So f4 minus 4f3 plus 6f2 minus 4f1 plus f0. And from the table, so here, so in the table f4 and f1 are missing, but all the values are given. So if we put these values from the table, we will get f4 minus 60 plus 48 minus 4f1 plus 0. f0 is 0, 0. So final equation is f4 minus 4f1 equals to 12. This is our second equation. Again, if we put x equals to 1, we will get the another equation 4f4 minus f1 equals to 93. So this is the third equation. If we solve 2 and 3, we will get f1 equals to 3 and f4 equals to 24. Okay. We solve one more equation problem. If fx is a polynomial of degree 3 and f0 equals to minus 1, f1 equals to 5, f2 equals to 13, f3 36, f4 69, where it is given that f2 is not correct, find the error. So f2 is not correct means there is something missing, and we consider this the error. So we consider here, so f2 exact value, this is exact value 13, and now we apply the forward difference. If we apply forward difference operator, here we apply the forward difference. This is the table fx, and f2 is 13 plus epsilon, and this is the table here. Okay, so I think all of you know the delta fx means f of x plus h minus delta fx, or another way y0, so y1 minus y0. So this is the y0 and this is y1. So delta y0 means y1 minus y0. Doing like this, we can find this one, delta q y0. This is the delta q y0 and this is delta q y1. And since it is given this the polynomial of degree 3, obviously is degree 3 means the delta cube y obviously a constant f of fx, because this is the polynomial, third degree polynomial. If we apply the forward difference operator, obviously the delta 3 fx obviously constant. So as this is the constant, these two terms must be equal because of a constant. So 13 minus 3 epsilon equals to minus 5 plus 3 epsilon, that is epsilon equals to 3, that is 6 epsilon equals to 13 plus 5 18. So epsilon equals to 3. So that is the correct value is f2 equals to 3 plus epsilon, that is 13 plus 3 equals to 16. Thank you.